Hey, what's going on, everybody? Today is December 10th, 2024, and you're watching the Daily AI Show live. And, the Daily AI Show, if you're just finding us, first thing, is a great resource. We're here every single weekday. We've done this now 350 plus times. We haven't missed a weekday yet in over a year. We're sort of your one-stop shop. If you want to keep up with everything that's going on in AI, then you can join us. You can be part of the conversation. You can go over to YouTube and join us in the comments and, be part of what we're talking about live, or obviously you might be catching us up on the replays as well. Also, you can go to the dailyaishow.com and learn anything about any of the shows we've done in the past. And also, more importantly, you can sign up for our free newsletter there. Our newsletter, like I said, is free, goes out every Sunday at 8 a.m. Eastern. And that's really where you can do a deeper dive into any of these topics that we're talking about day to day. It gives us an ability to go beyond what we can cover just in these live shows. So if you like to nerd out with us, if you like AI, then you should definitely go over and sign up for that newsletter as well. With me today, I have Beth, Andy, and I'm Brian. And today, if you saw the title card at the top, you might have missed it. It's sort of about this idea of picking the right types of data. And this comes out of an MIT, not study, but something that came out of MIT research. And what it's called is model-based transfer learning, or MBTL. And now we're going to dive into this a lot more. And I can't wait to hear what you guys have to say about it. But just as a high level, the idea here is here was the pain point. Let's put it that way. The pain point with training algorithms or using algorithms and training models was that you can go super specific or you can go broad. I'm just big paint strokes here, okay? And they have their pluses and minuses to it, but they can also be very, very costly. And so what my MIT did in this study that we'll dive into in a second is they said, okay, hold on a second. What if there was a better way to strategically pick the right types of training that would then help the bigger model all the way across? And so in this article that came out from news.mit.edu, it does a really good job of using an analogy of traffic lights. And so in this context, just to sort of set the stage here, the idea would be if you needed to create a model that helped traffic lights work more efficiently, you have a couple different ways to do that. You could say broadly, this is how traffic lights work. Okay, model, do your best to help the traffic light on the corner of walk and don't walk do what it needs to do. Or you could, from an expensive side, go, hey, I'm going to train on every single intersection, every single traffic light in the city, and I'm going to use that data to then inform everything. But it'll be trained on every single task along the way. But both of those have their pluses and minuses, and that's where this model-based transfer learning really comes into play. Okay, so I'm going to pause there. Andy, Beth, take it from there. Dive into this a little bit more, and we'll dive into what they sort of found and really some innovative ways that they've worked around this pain point.
Yeah, Kathy Wu is the principal researcher at MIT who came up with MBTL. And this is more than an analogy. This is her lifelong passion, is understanding the complex problems that apply in logistics and also in the real world example of how do we manage a city with multiple traffic intersections and improve or optimize its route management in there. Because how many times have you gone to a traffic light and you're sitting there for seems like minutes and there's still nobody coming from the other directions.
Right. Yeah.
And you're saying, why is my engine running here? Okay, well, the car manufacturers fix that, I think, a little bit, either electric vehicles or whatever. But she has this personal lifelong mission to reduce the idling and reacceleration costs of vehicles having to stop unnecessarily. So her whole mission at MIT, and she has a group of researchers with her that are, PhD students who have been working on this for years. I looked back and there's an article in MIT written about her from 2023 early about this project underway, but they've arrived at something that has generalizable application to complex problems broadly. but it's been out of the focus that she has on this traffic engineering question. So what she's trying to get AI and machine learning to be able to coordinate the timing of vehicles in a big network of intersections so that they arrive when the traffic lights are green. Now you can imagine the timing issues that are having. So we're coordinating multiple locations. And so that will eliminate the start, stop, reaccelerate problem that she's identified. In doing that, they've built an ecosystem of tools, data sets, and methods. And the MBTL is a method that they've applied to this to enable these roadway interventions. But this is what can be applied to many other complex problems like this.
Yeah.
Well, it's all about route optimization. And what my simple takeaway on it is that instead of trying to train a single algorithm that will apply to all of your traffic lights by understanding every traffic light in the place, they can, which is a really, really compute intensive problem, both for training and for inference. Like when you put this AI to work in the city to start changing the timing of lights in real time, that's a very complex and costly process. But they found that they could run this other program that would determine this MBTL, the transfer learning program, that would learn which of the intersections data made the biggest advances in the capabilities of other intersections. Like that. Okay, so it's transferring knowledge about this intersection to another intersection's kind of algorithmic approach to managing itself. And when you put that process in place, what appears is out of all the data that's coming from all these intersections, there are certain intersections that seem to have more information or more useful or practical or transferable information in the training process. So then they get to the point where they can say, okay, wow, we get 80% of the value of training by just training all the intersections on these 7. Okay. These 7 happen to, be the font of knowledge for this particular problem. And then we can get to the solution and a really advanced one. And they say 5 to 50 times improvement by
in efficiency.
Just those important data sets and then training only on those and not on all the rest.
Right. I'm so excited that you use the word generalizable because not only is this applicable broadly, but generalization is also what the model is doing, right? Because and that's like if you've trained a dog, and I have trained several, or raised a child, you know that there are stages at which their understanding of the world starts to generalize. Right. So it starts like with a cause and an effect. You do something and you get this reward. Right. Or like with a kid, you hit the light switch and the light goes on. Right. Can they generalize to a different kind of light switch? Can they generalize that you push it instead of flip it? Right. Those sorts of things. Dogs generalize in environments. And that is really interesting because that in and of itself is an indication of both intelligence and a sense of understanding the being able to understand patterns that you want to introduce, right? Because we understand that they're understanding patterns that we don't even know, right? Like we're not understanding the patterns that they're understanding, but now these are patterns that you can introduce or kind of request that I'm giving you these data sets because these are the best ones. And I guess actually they also told us these are the best ones to give us, right? Like
that's the idea, right? That it's like
right.
it's hand picking, if you will, the one that it feels will make the sequentially. It's picking the right task that has the biggest impact, like Andy you just said, and then it's sequentially going and saying, well, what would the next best task be after that, right? Which is really, really cool. Also, what I found fascinating, Beth, is that this uses it's counterintuitive at first. It uses zero-shot learning, prompting. It's not saying, hey, here's this intersection and we've trained on it. It's identified that the task at this intersection is what we want to train on. And then we're going to give that example to the next intersection. It's just training on, it's allowing it to build off of it, which I think is more in what you're talking about, at least the way I understand it, with the generalization. It's not saying specifically, here are some guardrails. It's saying based on how this one task was computed, it's like the neighbor effect, right? Here's how you should maybe work as a neighbor. And so I was thinking about this in terms of training as an analogy. You guys know I like try to work it out in my head. And so just yesterday, my daughter came home from school and we were talking about the singer-songwriter Gracie Abrams, who is really kind of popped up. She has this, I hate to categorize her as a Taylor Swift, but it's a very Taylor Swift type sound, I guess. Gracie Abrams. Anyway, my daughter is a big fan of her. And we were talking about one of the songs because it was stuck in my head. And so I was singing around the kitchen and I was like, you know, that's probably a really easy guitar lick. I mean, I've seen her on many videos and stuff like that, and she's strumming an acoustic guitar. And I was like, that sounds like something that's in my repertoire. I'm not some virtuoso on guitar. I was self-taught years ago when I was a teenager because I thought it would get me to talk to girls. And then, you know, like you got to have the reasons why you learn how to play guitar when you're young. And so I taught myself. And then so I was showing my daughter and I looked it up. There's a tab thing that you can look up and find the thing. It's okay. And within about 2 minutes, she was singing along and I was strumming and playing the song. As I suspected from hearing it, it was a fairly easy chord progression as well as a fairly easy strumming pattern. And I was able to pick it up pretty quickly over years of doing it. But then came the questions from my daughter. How do you know how to strum like that? How do you know where to put your fingers? How do you know what chords it's telling you on the app? She had tons of questions. How would I learn to do that? And so this is where the analogy comes in. I could start teaching my daughter how to play guitar, but it is going to be all over the damn map. I have no process or plan in place for what tasks are the best, first, and most influential tasks to show my daughter on how to play guitar. I do not teach guitar. And my way of teaching guitar is going to be wrong. It's going to be costly. It's going to be costly in terms of time, you know, and attention. It could potentially send my daughter down the wrong path by learning the wrong chords in the wrong order. You know, maybe you're supposed to single pick before you strum. I don't know. I don't remember how I learned to do it when I was 16. I'm sure I did it the wrong way. That was before the internet. I didn't have the internet to just learn how to play guitar and watch a YouTube video. So when I thought about this, and as I was researching today, I'm like, you know, it's the same idea that if there's an algorithm that says, okay, Sophia wants to learn how to play the guitar, let's figure out the top 5 or 10 identified best tasks of learning how to play guitar that are going to net the best results for Sophia. That's the most efficient with her time, her money, to generate the end results to it. That's where my brain went with this. It's the idea of pre-selecting, using this MBTL to pre-select the best tasks that are going to have the biggest impact. And so they even say it in the article about this. Oh no, I scrolled too far. Oh no. It had a really good point to it. Oh, here it says, from the perspective of the two main approaches, that means the data from the other 98 tasks was not necessary, or that the training on all 100 tasks is confusing to the algorithm. So the performance ends up being worse than ours. That's a quote from Wu. So she's talking about having the MBTL, but I love that second part about the 100 tasks actually might be confusing. It might be doing damage, no different than me saying, okay, forget that. Let me show you a G chord. Okay. C, G, D. That's all you need to know in a guitar. That's super confusing to my daughter if I have no plan in place. You know, she'll be like, okay, where do I focus my time? He's told me 10 things. I have no idea which one I'm supposed to focus on first. So It's that confusing, you know?
Because it's introduced patterns that we don't know. We're not seeing the patterns in the 100 pieces of data. So yes, if you're just doing the most essential, then you are then you're reducing the sort of human can't identify all the patterns that they just introduced. That's a really good point.
Let me describe what these complex problems look like, because I love the analogy of teaching guitar. But a guitar is pretty confined. It's not, one guitar is like every other guitar, right? It's six-string
Be
guitar.
careful.
Like
You're gonna make some
that.
people
I
happy
play
now.
bass guitar, so it's different. But so anyway, think about the traffic optimization problem. So one intersection is not like another, right?
Mhm.
Some have 2 lanes at each of the 4, intersecting lanes. Some of them have, crossways, pedestrian traffic. You can go diagonally across the thing, like in Japan.
Mhm.
There's different grades. Like what happens this intersection, we trained this algorithm on this, but now at this intersection, this direction is on a steep hill. So coming up, that hill's different. And then figure out that you have to also include time of day and the demands on traffic and movement through that particular intersection. The temperature may make a difference. All of these little factors have to be fed into the algorithm for a new intersection. And then the question is, do I have enough examples of all these different configurations that the algorithm that I'm building to be applicable generally to any new intersection that I want to add this algorithm to manage its own, traffic lights? Do I have enough information in there? And this is where the confusion comes in. Like some of the examples are just not generalizable. Like if I pick this intersection, it's got the steep on-ramp and a weird, diagonal cross intersection for pedestrian traffic, that's not going to be a good one to train on for the generalized algorithm or the transfer learning approach. So, but it also points to a bigger issue here, which is, it's not going to be possible to put a single AI in sensing only that one intersection and have it work reliably in the bigger problem of how do I change the traffic over here at 7:58 so that on the other side of the city, if you're crossing the city, this light is going to be green when you get there.
Yeah, right.
It's like, whoa, mind-boggling. But AI can actually approximate those kinds of things if it has enough sensors and it can figure out how to model that. And then we get to talk about quantum computing, which can do these kinds of calculations that are so large with so many variables in much faster time. And there's big news yesterday from Google about quantum computing that Carl shared with me. Anyway, we'll talk about that. But we're entering into an era when even these very vastly complicated multivariable problems will be solvable. And I hope one day we will never have to stop at a red light again.
Yeah, if nothing else, like I always think, well, I think driverless cars are also going to be a huge impact here, which isn't necessarily what we're talking about today. But if driverless cars, like if I'm not driving the car, am I as aware that we're doing 65 and not 75? If I'm driving, I'm like 75, let's do it. But so is everybody else, and it causes traffic jams. And so I think this same type of technology will be applied to traffic jams. Now I'm not even talking about, like I'm talking about on a highway, go out to California and, any of the traffic around DC or, any of those places like Atlanta now, unfortunately. And you get the traffic jams. And some of that can probably be fixed through algorithms at, like, in Atlanta, I know they have the go, don't go traffic lights, and whether people follow that or not. But like the idea right now is like, let people into the flow of the expressways at intervals. And that helps with the jamming up and stuff. But I would imagine this same concept can be applied in those scenarios as well. Highly specific to road conditions and all that, time of day, weather, all that stuff. I mean, I know I learned the hard way 2 years ago when I was over in Seattle. There was a huge snowstorm. We went out for Christmas and it snowed. It locked down the city. And here I am, not really having a whole lot of history driving in snow, now in a minivan with my in-laws, my wife and my daughter, trying to get around the hills of downtown Seattle. And absolutely, different intersections behave quite differently, as you were looking at the steep of the grade and thinking, I don't want to slide down that hill sideways in the snow and the ice, and so like you said, Andy, like when you put in all the variables, we can't comprehend it necessarily, but either through the quantum, through the generalization you're saying, Beth, I feel like they're showing that this is solvable, but more importantly, it's solvable at a much reduced cost. And that's really the interesting part to me, is that you do not have to throw all of your available data at the problem to actually get a better result. And I think that's probably counterintuitive to the way a lot of people think about it, is more data, better solution. And what they're showing is no, carefully curated better data becomes a better solution. By the way, Karl joined us a little bit a while ago, and we was sort of chatting. But Karl, any thoughts or comments on this study and what they did with the MBTL, the algorithm?
No. Actually, my favorite comment is, when you were talking about your guitar and you wouldn't know where to begin. My first thing is, wait a minute. There's a bunch of people who are training other new drivers, and that's why we're leading to more terrible drivers.
Right.
That's how I made it. I was like, you got terrible drivers training new drivers. It's like, well, they don't. So that's where my thought was.
Way bigger problem than guitar.
Yeah, exactly, guitar. So that's where I thought. And then another thought, which has nothing to do with this, is when you talk about driverless cars, I think improvements in traffic. I'm not sure we're gonna get the improvements just because of better traffic light and traffic pattern intervals. I think you get the true benefit if everyone is in a driverless car, because then everyone is actually going the same speed.
Right.
Way better than right now, right? People are going all sorts of speeds, and that usually leads to delays and whatnot because some people go faster and whatever. So I feel like if everyone was going the same speed and people were in the fast lane and the slow lane and you're going, I think that's where you'll see the really efficient. So, you're going slower, but everyone's going slower. So you're actually getting there faster. It's super consistent. And then you're like, oh, how long will it take me to get to there? It's like, you're actually going to get there. The accuracy of the timing will be so much better, right? That's why, but I don't think it'll be maybe generations, because some people, I was talking to some prospects yesterday, and they're got into driverless cars, and one person, he was older, and he said, the new generation will want those driverless cars because they want to be efficient, but some of us old folk want to continue driving, and it's the driving that is the fun part of it, not the getting around. So there's two different things. So it's like, and he was talking about a Ferrari, loves a Ferrari or something, but that was I was like, oh, that's interesting, because some people enjoy the process of it. Sure, versus I'm going to go from point A to point B. That's the whole point I have.
Otherwise, why have a stick over an automatic, right?
Yeah.
Some people just straight up prefer sticks.
So this raises the point about the AI control. Like right now, this is a very complicated problem to just try to optimize the timing of traffic lights. And all the autonomous vehicles like Waymo, they still have to come to the thing, see, oh, it's red, I got to stop. There's no communication between the AI and the vehicles. But imagine a now somewhat distant future because of the cultural opposition that, I don't want to give up my steering wheel. Imagine a future where now the AI not only has control over the lights, but also has control over the speed of the vehicles and the path of the vehicles. So it's going to shunt or shuttle, a certain amount of traffic over this way in order to make it possible for those vehicles to continue going through green lights. And then that reduces the traffic in this area that allows these vehicles to go through green lights. And there you're reducing the overall carbon footprint of the management of getting around, which is really the full optimization of traffic management, right? And then you throw in the rogue cowboy who's got his pickup truck and is never going to give it up. And then the AI has to figure out how to handle that guy. We're going to put him on the red light here for a long time.
I think and this is really, really a big piece of where I'm looking at, and sometimes where electric vehicles may or may not make sense, and especially autonomous vehicles in cold weather climate, places like Calgary, Edmonton, where it's not just cold, you have snow, ice. So I'm very curious because it's much easier when the weather and the road conditions are predictable. But when the road conditions are not predictable, especially in residential areas, most highways, they get the initial salting, they're usually cleared first. But all the, if you start driving in, if you get your driverless car to go into those places, I haven't seen any tests with that. So it's like, well, I know probably it'll be another 3, 4, 5, 6, 7 years before something like that enters our market, because the weather is just an X factor.
Yeah,
on
snow and ice.
I don't know, like, the same parameters that you're driving or driverless car in a cold weather environment versus warm weather is two different things. So like, imagine in Tampa and Orlando, I would imagine, outside of rain, it's probably more predictable than, hey, like certain residential neighborhoods, you got like 4 or 5 feet of snow. You probably want to avoid that. And imagine your driverless car trying to get up a hill that, like, it's spinning. What is it going to do? You're probably going to stop in the middle and be like, well, can't go further. And then, most people would dig this thing out. But like, if it doesn't have a steering wheel, what are you going to do? Just like, well, I can't do anything, I gotta leave. So I'm curious to see how they deal with that.
Yeah, it's better in LA.
Yeah.
Yeah, thanks, Carl. I don't know, Carl. I don't know if you're hearing on your side, but you got an echo on your mic. What I was gonna say is, yeah, I mean, obviously in Florida, we're a pretty flat state. We don't have hills around here, and we don't have snow, and so yeah, it's pretty predictable. I mean, Orlando has horrible traffic on I-4 through parts of the city and stuff, and they've worked for now decades since I lived there to try to fix those things and reroute traffic patterns or whatever. But I like the idea that all of this coming together is eventually going to make a difference, and I think what I probably see is Florida has a lot of toll roads. I guess that's not that uncommon anymore, but Florida used to be known for having more toll roads than other states. It's always been the case. They're usually pretty quick. I have one right down the street from me that we use quite a bit to get to like the airport and stuff. The reason I'm bringing it up though is that it's got an express lane. That express lane doesn't cost more. It just doesn't have a way to get out of the express lane for about 4 or 5 exits. So if I'm going to go to the airport from my house, I can pop in this express lane, and me and everybody else in that lane are all going the same direction and won't be getting off for 5 miles, 10 miles, whatever it is. And then there's places for you to get out. The reason I bring that up is I would imagine down the road, as we get to more autonomous vehicles, and that's a more common thing, robo-taxis, whatever, that you will have these lanes that are specifically they're express lanes for autonomous vehicles. And I think that's where we'll see that hybrid approach of the guy in the truck who's always, or the guy in the Ferrari, the girl, whatever, that are always going to do the stick shift. They're never going to have an autonomous car until somebody forces them into it, or there's such tax incentives that they don't do it or whatever. And then, but that's probably decades away. I mean, there's millions of cars on the road. They're not going to disappear tomorrow. So I think there'll be some hybrid is what I'm trying to say. And there'll be probably isolated lanes the way we do for high occupancy vehicles, HOV lanes, or your toll type situations. I know going through, like, I think DC and Atlanta's like this, where you could pay a little bit more to be in that, you're pay to play. Basically, you're paying to get somewhere faster. And so you might pop in this express lane and pay $2, but it gets you home 15 minutes earlier, and you deem that worthwhile or whatever. It's sort of the fast pass, right? So anyway, I think there's a lot to be that, like, will come to this. And then obviously, like this MBTL and what they're working on with Dr. Wu, this will be really interesting. My question to you guys is, we've sort of talked about the because this is what it was built for, but can you guys think of any other immediate use cases where this MBTL type algorithm would be helpful, that it seems like it would have an immediate impact? Obviously, they talked about traffic lights and all that, but are there any other ones that you could feel like, hey, you know what? If you were a business or whatever, I could see how this might be have a huge impact right away for cost savings, amount of data that you need, whatever the reason is.
I can't see of a business, but I can see the NFL. Like, imagine you had this back to, it's like as games go, it learns. So imagine teams being able to real time this. And was I talking about this yesterday?
We talked about it yesterday on the show.
Yes, yeah. I don't know why it just keeps coming up.
Yeah, I get it.
But anything that goes to sports, being able to see the repetitions and then the tendency and then adjusting your side for that, to me is a very fascinating kind of industry usage of that. And then would that be then kind of like AI doping or AI like cheating? Because how far does that go? And that contains any kind of sport, right? Whether it's team sport, I don't know about individual sport. I think that's a little bit different, but like, yeah, I can kind of see where you'd have that advantage. But then if you think about too, if you go to energy or drilling or whatnot, then you can start seeing like patterns of what you're doing, where your vehicles are, what your machines are. And then over time, especially in like major sites, I can see like it's more of an advanced deployment of from an efficiency standpoint and how best to extract, what you're trying to extract and then what you're trying to refine as well. I don't know enough, but I can see those who have the expertise in this, who, if they kind of got the premise of this, can kind of merge those two pieces together.
What I keep thinking of, and Andy, I wonder if this is something that is bouncing in your head too. We did a show on Life 3.0 by Max Tegmark. And I'm saying Andy because the reason we did the show is because Andy said we should do the show. But one of the things that was like this kind of evolution of AI helping to train more impactful and more like improving AI, because AI has shown how to improve AI, right? So self-optimization, the efficiency scaling, this seems to be a little window into, right? Because again, in the power conversations that we have about how much power it takes to train, that's again because we're just like we're making a really big stew, right? We're just taking everything we've got and then we're just sitting in a room. Wow, this analogy is going to go really badly. We're just locking it into a room for a little while with a bunch of heat, and then we're seeing like what comes out, and that would be nasty. Okay, Andy, save me.
I love where that went, Beth. You're just like, this is. I'm losing it. It's going off the edge. Okay, here we go.
Commit to the bit, man.
Live shows,
right? I think you're making a great point about the approach that's been taken to scale artificial intelligence at this point, which is let's give it more data, not necessarily the best data. And this show is about what happens if you figure out first, you do some pre-processing of the data that tells you which parts of the data are really instrumental in getting to a truly intelligent, responsive agent. But in answer to the question, where else could this be applied? I immediately thought about agriculture. Like robotic agriculture is going to have to be, a big thing, and you're going to have more than one autonomous actor in the fields, let's say, and you want to make sure that the training of those is good enough that the combine doesn't run over the strawberry picker, okay, that sort of thing. And then just generally in massive, complex, multi-step logistics chains, the supply chains that go, start out in Europe or in Africa or wherever. Oh, sorry about that. And how to manage the movement of containers, from each port of exit, or, like first by trucks and all of that.
Yeah.
Very complicated modeling that's required there. That's probably very expensive to train. Where do you get the data, and how do you feed it the data and let the AI know? You don't want the AI to hallucinate and send, a container ship, in the wrong direction. This MBTL approach is really generalizable to all logistics problems, and even the most complex in global supply chains.
I think that's where we're going to actually feel it. I think this goes to the comment that Sam Altman had on a recent interview that he did. I was just watching it yesterday, I think, where he was talking about AGI and super intelligence, and the same questions he gets a lot about, like, when's AGI coming? And he said it enough times now. Like, I think we're going to have like specialized AGI in certain areas. This is one of those areas where we may blink, for lack of a better word, and then go, oh yeah, remember when traffic lights were yada yada? But other areas outside of traffic lights are plane travel, because back in '96 during the Olympics, before I went to college, I was a baggage handler at Delta Airlines. And, back then in '96, you would sit in this little room underneath the concourse, right? Because you were in like your go, no go. And, you get these little green ANSI screens that would tell you the plane is about to show up at the gate, and you'd peek out the window and be like, there's no plane there. And then the green ANSI screen would be like, the plane's definitely there. And you'd be like, there's definitely no plane at my gate. There's nothing for me to do. And this is the process for the entire summer that I work there, right? Cut to 2024 or a near future with these type of algorithms, what you might find is these same baggage handlers sitting in the room, and it may have a countdown on it. It says that walk to gate 26 to start doing it in, even though the plane is there, don't walk out to the gate for another 7 minutes. And you're like, but I could start right now. But the algorithm knows it's actually more efficient for you to delay walking out to that plane for 7 minutes because of 1,000 different parameters that would be too hard for a human to really, wrap your head around, or that gate agent to be like, or a baggage handler to be like, well, that makes sense or doesn't. So what does that mean? Well, I think it means more efficient travel, less delayed flights for everybody. I think you nailed it when you talked about ports. I mentioned this before, but not at my current company, but previous company, a client of ours was Port Tampa Bay. And so I got a brief look into how complex ports are. That was a very eye-opening experience. I'm so grateful for it, because I would have never really thought about what the complexities of Port Tampa Bay are, but holy moly, is it really, really complex when you're talking about connexes and trains and the trucks and everybody unloading. And we saw a lot of that backup and that breakdown during COVID. We saw all of that when you couldn't get toilet paper because it couldn't get on the Connex, because it couldn't get across the sea, yada, yada, yada. Algorithms will probably help us see that. And then obviously last mile delivery, when you have places like Amazon who already use tons of algorithms to try to be as efficient and highly optimized. But we have one of those distribution centers right down the street from me. And if you catch it at the right time, it's funny. It looks like a Coke commercial at Christmas where all the Coke trucks are coming down the road together in like a caravan, because like if you check this one light, there'll be 30 deep Amazon Rivian trucks. They all left the distribution center at the same time because their shift started at 7 a.m. And I always think, well, that's silly. That back guy or girl is going to sit at that light for 4 iterations. Maybe there's a better way, back to the traffic light scenario, and Amazon to know that doesn't make any damn sense. Keep the charge on the Rivian. Don't leave it. Don't unplug and go out in spurts or whatever, because it's raining today and it's also summer in Florida, and all these things mean something based on our data. And so this is how we're going to send people out to get that last mile delivery and stuff. So whereas we may not use something like this in our own personal businesses, I do feel like this is a Sam Altman type comment where he says, it's going to happen faster than we expect, but in certain areas. And I don't know that even if this happens fast, we'll necessarily stop and go, hey, remember when we used to wait at this light longer? You just won't. And that'll be the new normal. And traffic will get a little bit lighter, and maybe plane travel will have less delays. And we will just move on with our lives and never really stop to think without shows like this and go, is that AGI? It might be. It might be a version of that. And we're just not paying attention to it because it wasn't all powerful. It just fixed that problem. And I think, MBTL could be a huge, obviously, part of that solution.
And what you're talking about in terms of Amazon is perhaps analogous or like a next level step from what they do in their shipment centers and their warehouses, right? Because for years we've been hearing about their efficiency, that it's not efficient to put like the whole case of them accessible in the thing. We just put 2 here because that's going to save, I don't know, 5 minutes in packing the box.
Yeah.
So yeah, I mean, I could totally see Amazon saying, wow, that's a great idea, Brian. We should use that.
Listen, I am sure Amazon is knee deep in algorithms and what they're doing, and they may be deploying something similar to this. Who knows? But anyway, it's a great idea. To your point, I think you said, Beth, of AI training AI, and you went back to the Max Tegmark book and the idea of Prometheus. In the book, I don't remember the specifics, but within hours, it was Prometheus version 4.0. It had iterated on itself 4 times to become super intelligent and so on and so forth within the course of a day. And I do think we will see some versions of that, whether we see it publicly, whether it ever meets the news cycle, or perhaps it'll reach us because we're always looking at this stuff. I don't know. I think some of this stuff will just happen, and we really won't be there or present enough with going on through our daily lives. It'll just become this new efficiency that nobody really stops to think like, oh, that was a significant AGI leap in this niche area. And it's due to reinforcement learning. It's due to these algorithms, training algorithms to become more efficient, cheaper, which obviously is going to be good for everybody if you don't need mountains of data, and it's much more cost effective to train them.
So we're not going to know until the actual outcomes that Carl and the chat are talking about in terms of the NFL. And then everyone's going to know about it.
Right. Yeah, exactly. It has to hit what people care about in the zeitgeist, right? It's got to be the public thing. Okay. If you guys are good with it, we'll wrap up the conversation there. Want to just do a quick call out. Don't forget, later on today, we've been doing this every day so far. OpenAI currently has the 12 days of OpenAI. Today would be day 4. They've already come out swinging on days 1 through 3. They announced O1 coming out of preview. The second day, they talked about different ways that you could use O1. On the first day, they also talked about ChatGPT Pro. And then yesterday, day 3, because they skipped a weekend, they finally released Sora. And so we've had an opportunity, or at least I've had an opportunity, to play around and create some videos in Sora. Very hit or miss. I'm sure we'll talk about that on another show. So today is day 4, and we're doing our live reactions. Whoever's available for the day will jump on here. And so we've been doing 2 live sessions a day. Come back and even if you don't catch us before today, we're going to be doing it for all 12 days. So that's all the way through this Friday, and then Monday through Friday the following week. I think that ends up being day 12. So 1 p.m. Eastern, 10 a.m. Pacific, for the rest of this week. Come back and join us as we learn right along with you live, whatever the latest announcement is. Now, yesterday was Sora. Will today be GPT 5? I don't know. It might be a stocking stuffer, but we will find out together. So that's what's going on. Don't forget, you can sign up for the newsletter by going to thedailyishow.com. And we, of course, will be back live the rest of this week and every weekday with our regular show at 10 a.m. Eastern, 7 a.m. Pacific. So thank you, everybody. Fun conversation today. Curious to see where this goes in the future. And we will see you back in just over 2 hours. Until then, bye.